Imagine standing beneath a calm afternoon sky. The air feels warm, birds are singing, and everything seems perfectly normal. But somewhere beyond the horizon, nature is quietly assembling one of its most terrifying weapons. Within minutes, that peaceful sky can transform into a scene of chaos. Clouds begin to rotate, winds intensify. A dark funnel descends from the heavens. Trees bend, buildings shake, cars are lifted into the air like toys. This is the terrifying reality of a tornado. Among all weather phenomena on Earth, tornadoes are some of the most violent, unpredictable, and destructive forces ever observed. They can appear suddenly, grow rapidly, and leave behind trails of devastation that stretch for miles. Despite advances in modern science, tornadoes continue to challenge meteorologists and remind humanity of nature's incredible power. A tornado is a rapidly rotating column of air that extends from a thunderstorm cloud to the ground. Although many tornadoes are relatively small, the most powerful ones can generate wind speeds exceeding 300 miles per hour, or nearly 500 kilometers per hour. At those speeds, entire houses can be ripped from their foundations, steel structures can be twisted, and massive objects can become deadly projectiles. What makes tornadoes especially frightening is their concentrated power. Unlike hurricanes, which affect large regions over many days, tornadoes often strike with little warning and focus immense energy into a relatively narrow path. A tornado only a few hundred meters wide can completely destroy one neighborhood while leaving another nearby almost untouched. The story of a tornado begins inside a powerful thunderstorm known as a supercell. These storms are among the most organized and dangerous weather systems on Earth. Inside a supercell, warm, moist air rises rapidly, while cooler air descends. Strong wind shear causes winds at different altitudes to move at different speeds and directions. This difference in wind movement creates invisible horizontal tubes of spinning air. As powerful updrafts lift these spinning tubes vertically, they begin rotating around a vertical axis. The storm develops a rotating core called a mesocyclone. As the mesocyclone intensifies, rotation becomes tighter and faster. The pressure inside the rotating column drops. Moisture condenses, and a visible funnel cloud begins extending downward from the storm base. When that funnel finally reaches the ground, a tornado is born. At first, it may appear almost beautiful, a slender, twisting rope hanging from dark clouds, but appearances can be deceiving. Within moments, that narrow funnel can expand into a massive wedge tornado, wider than several football fields combined. Meteorologists classify tornadoes using the Enhanced Fujita scale, commonly known as the EF scale. This system estimates tornado strength based on the damage left behind. An EF0 tornado produces winds between 65 and 85 miles per hour. It may damage roofs, break tree branches, and overturn lightweight objects. An EF1 tornado is stronger, causing more significant structural damage and uprooting small trees. An EF2 tornado can tear roofs from homes and cause major destruction to buildings. An EF3 tornado is considered severe and can destroy entire sections of neighborhoods. An EF4 tornado causes devastating damage, flattening well-built houses and tossing vehicles considerable distances. At the highest level stands the E5 tornado. These monsters can generate winds exceeding 200 miles per hour. Entire communities can be erased within minutes. Concrete structures can be severely damaged. Massive steel objects can be bent and twisted. Survival becomes extremely difficult for anyone caught directly in their path. One of the most famous tornado regions on Earth is Tornado Alley in the central United States. This vast area stretches across states such as Texas, Oklahoma, Kansas, Nebraska, and parts of South Dakota. The geography of this region creates ideal conditions for tornado formation. Warm, moist air flows northward from the Gulf of Mexico. Cold, dry air descends from Canada. Dry air from the Rocky Mountains moves eastward. When these contrasting air masses collide, the atmosphere becomes highly unstable. The result is a breeding ground for some of the world's most powerful thunderstorms and tornadoes. Every year, the United States experiences more tornadoes than any other country. Hundreds occur annually, ranging from weak and short-lived funnels to violent storms capable of catastrophic destruction. Yet tornadoes are not exclusive to North America. They have been observed on every continent except Antarctica. Countries including Canada, Argentina, Brazil, Bangladesh, India, South Africa, Australia, Germany, and the United Kingdom all experience tornadoes. Bangladesh, in particular, has witnessed some of the deadliest tornadoes in recorded history. Due to high population density and vulnerable infrastructure, even moderate tornadoes can have devastating consequences. One of the most catastrophic tornadoes ever recorded struck the Manikganj district of Bangladesh on April 26, 1989. Known as the Daulatpur Sataria tornado, it carved a path of destruction across villages and towns. Entire communities were devastated. Thousands were injured, and well over 1,000 lives were lost. It remains one of the deadliest tornado disasters ever documented. The sheer force of a tornado can be difficult to comprehend. Inside a tornado, winds rotate at extraordinary speeds, while air pressure drops dramatically. This combination creates immense destructive potential. Buildings may experience both external wind pressure and internal pressure differences that contribute to structural failure. Objects become airborne missiles. A wooden plank traveling at tornado speeds can penetrate walls. Metal sheets can fly through the air like blades. Vehicles weighing several tons may be rolled, tossed, or carried hundreds of meters. Researchers studying tornado damage have documented astonishing examples of their power. Pieces of straw have been found embedded in tree trunks. Heavy machinery has been moved significant distances. Entire homes have vanished, leaving only empty foundations behind. Yet, despite their destructive reputation, tornadoes vary greatly in appearance. Some tornadoes are thin and rope-like. Others resemble giant wedges stretching across the landscape. Some appear nearly transparent, while others become dark with dirt, debris, and dust. There are even multiple vortex tornadoes, among the most dangerous forms ever observed. Instead of a single rotating column, these tornadoes contain several smaller vortices rotating around a central core. Each vortex may possess extremely intense winds, capable of causing concentrated zones of severe destruction. To an observer, a multiple vortex tornado can look chaotic and unpredictable, with damage patterns that vary dramatically across short distances. Modern technology has transformed our understanding of tornadoes. Meteorologists use Doppler radar systems to detect rotation inside thunderstorms. These advanced instruments measure the movement of precipitation particles, allowing scientists to identify areas where tornadoes may be developing. Satellite imagery provides large-scale views of weather systems. Computer models simulate atmospheric conditions. Storm chasers gather valuable data by positioning themselves near severe storms. Storm chasing has become one of the most dramatic aspects of modern meteorology. Teams of scientists and weather enthusiasts travel thousands of miles each year across tornado-prone regions. Their goal is to observe storms, collect data, improve forecasting methods, and better understand tornado behavior. Armed with cameras, weather instruments, GPS systems, and communication equipment, they often find themselves face to face with nature's most violent storms. The footage they capture has revealed extraordinary details about tornado formation and structure. Some of the most iconic tornado images in history come from these daring expeditions. However, storm chasing is not without danger. Road conditions can deteriorate rapidly. Storms may change direction unexpectedly. Heavy rain can obscure visibility. Large hail, lightning, flash floods, and violent winds create constant hazards. Even experienced storm chasers must exercise extreme caution. One of the greatest challenges in tornado science is prediction. Meteorologists have become increasingly skilled at identifying environments favorable for tornado development. Severe weather warnings today are far more accurate than they were decades ago. Yet, predicting exactly where and when a tornado will touch down remains extraordinarily difficult. The atmosphere is a highly complex system. Tiny changes in temperature, humidity, wind direction, or storm structure can dramatically influence tornado formation. As a result, scientists continue developing more advanced forecasting techniques and technologies. When tornado warnings are issued, rapid action can save lives. The safest place during a tornado is typically a basement or underground shelter. If no basement is available, individuals should move to the lowest level of a sturdy building and stay away from windows. Interior rooms, hallways, and small enclosed spaces often provide better protection than exterior walls. Mobile homes are especially vulnerable during tornadoes and should be evacuated if safer shelter is available nearby. Vehicles are also dangerous places to remain during a tornado. Many tornado-related fatalities occur because people underestimate the storm's strength or attempt to outrun it. Preparedness is critical. Emergency kits, weather radios, communication plans, and awareness of local shelter locations can make a significant difference during severe weather events. Throughout history, tornadoes have left lasting marks on communities. Entire towns have been rebuilt after devastating storms. Survivors have shared remarkable stories of resilience and courage. Emergency responders have risked their lives to rescue victims trapped beneath debris. These stories remind us that while tornadoes can destroy structures, they cannot destroy human determination. Scientists continue investigating tornadoes using increasingly sophisticated tools. Mobile radar units scan storms in real time. Unmanned aerial systems gather atmospheric data. Artificial intelligence assists in weather forecasting. High-resolution simulations recreate storm environments with unprecedented detail. Each new discovery brings humanity closer to understanding these mysterious storms. Yet many questions remain unanswered. Why do some supercell thunderstorms produce tornadoes while others do not? What exact processes trigger tornado formation? Why do some tornadoes intensify rapidly while others weaken unexpectedly? These mysteries continue driving research efforts around the world. Interestingly, tornadoes are not unique to Earth. Scientists believe tornado-like vortices may exist on other planets. Dust devils have been observed on Mars. Massive atmospheric storms swirl across Jupiter and Saturn. Although different in scale and composition, these phenomena reveal that rotating atmospheric systems are a common feature of planetary weather. Back on Earth, climate researchers are studying how changing environmental conditions may influence severe storms in the future. While the relationship between climate change and tornado activity remains complex, scientists are actively examining long-term trends, regional patterns, and atmospheric shifts. The goal is not only to understand tornadoes today, but also to anticipate how weather hazards may evolve in coming decades. For many people, the sound of a tornado is unforgettable. Survivors often describe it as resembling a freight train rushing directly toward them. Others compare it to the roar of dozens of jet engines. The noise grows louder and louder until it overwhelms everything else. Then, suddenly, silence. In the aftermath, entire landscapes can be transformed. Roads become blocked by debris. Trees lie scattered across fields. Power lines hang broken. Buildings stand damaged or destroyed. Yet, amid the devastation, rescue crews arrive. Communities unite. Neighbors help one another rebuild. This cycle of destruction and recovery has repeated countless times throughout history. Tornadoes represent one of nature's most dramatic demonstrations of atmospheric energy. They form from invisible processes unfolding high above the earth, yet their effects can be seen long after the storm has passed. They inspire fear, fascination, scientific curiosity, and respect. Every tornado tells a story of atmospheric forces colliding on a colossal scale. Warm air and cold air, stability and instability, order and chaos. For a brief moment, these forces combine to create one of the most powerful phenomena our planet can produce: a rotating column of wind descending from the clouds, a force capable of reshaping landscapes, a reminder that despite all our technology, knowledge, and progress, nature still possesses powers that command respect. And somewhere beyond the horizon, beneath towering thunderclouds gathering strength in the distance, the atmosphere may already be preparing the next tornado, an invisible chain of events quietly unfolding, waiting for the moment when the sky begins to spin.